In the first video for 2-1, we spent time taking an equation, especially one called a vertex form, and creating the graph from it. Now we're going to use our graph with our key points on there and make the equation. For example 3, they give us a few steps we can follow. To simplify this process, we want to first identify your vertex. So find your HK, if you will, or your vertex. On this graph, we note that our vertex is at -2, 3. So I would say my vertex is -2, 3. We're going to put that in the equation. So remember, the form for your vertex is y equals a times x minus h squared plus k. We could think of the transformations from chapter 1 and remember that we're going to leave our y equals a here. But we're going to fill in these centerpieces. X will stay. This was our movement to the right and left, our horizontal translation. Well, we moved left 2. So remember, that means we're going to put a +2 because it's backwards of what we were thinking. Or if you're following the pattern, then -2 for the vertex x value is now +2 in here. Also, this 3 is how much we moved up, and this outside shifter was a 3 there. This is a great start right here to your vertex form for this graph. The only trick is we need to figure out what A is. A is your vertical stretch or compression. We will let you look at the original graph. Remember, the parent graph would go like this, starting at 0, 0, and it would always go over 1, up 1 in both directions. If you notice that happening on your next parabolas, you can just assume that A value is also 1. That'll be good enough for now. So that seems to be the case here. We have our vertex. It goes over 1 and down 1. Note that it is opening downwards. So that's going to mean that we have a negative for our A value, but it's also not really stretching or compressing compared to the parent function. It's still going over 1, down 1. So our A value is going to be -1. Now, we know our final equation then should be y equals -1 times x plus 2 quantity squared plus 3. This is your equation that we wrote from the key points of this graph. I want to show you what they're going to talk about in terms of their steps if you ever look at their answer key. They're going to set up this equation with the known vertex filled in, but they're going to encourage you to use this coordinate down here, another point on the graph, and plug it in. So for example, if I put a 0 in for x and a -1 in for y, I would have -1 equals a times 0 plus 2 squared plus 3. -1 equals a times, we have 2 plus 0 is 2, so we have 2 squared plus 3. I'm going to just keep solving this now for a. So this would be 4a plus 3. And I'm going to get the a alone, so I'll subtract 3 from both sides. I get -4 equals 4a. And looky there, if we divide by 4, -1 equals a. That's kind of a lot of work here for the same visualization that we got of just going over 1, down 1. But you can solve for a in that way by plugging in another xy point in for the x and the y in your basic vertex equation. This common error that they mention in the book is that you for sure should use this is your x value and this is your y value. Plug them into the correct spots into the equation if you choose to solve for a that way. All right, so now they give you another one on the try it. If the vertex is 1, -4, that'd be your HK. And it passes through this point here. This one's a little bit trickier because we don't have the graph. So we could make a sketch of it and use the symmetry to help us, but let's write our general vertex form, filling in our h and our k. So if it's a +1, that means it moves to the right one in the x direction. So we're going to write a -1 in our vertex form. It moved down 4, so we write the -4. To solve for the a, I'm going to put this x and this y in place of the variable they represent. So I would have my -1 in here. I'm sorry, my -2 in there for x. I almost made that common error there. And now I will continue to solve. By the powers of pausing and finishing the problem, I have plugged in and continued to simplify and got a to be 1/3, So my final equation would be y equals 1/3 times x minus 1 quantity squared minus 4. That is our vertex form. That's an equation for the parabola that fits these conditions. So for example 5, they're going to take two parabolas here. We have a parent function and a new transformed function. We're going to make two equations, a vertex form and a standard form. Remember, vertex form is really easy when you know what the vertex is and you can see that graph. So we'll use something like that. The standard form will be something that looks like ax squared plus bx plus c. Before we actually solve this problem, one thing I want you to note, when you take x plus 1 and you square it, you need to think of that as x plus 1 times x plus 1. This will involve some of that multiplication, the FOIL, the distribution. Maybe you remember doing a box problem where you'd have the x and the 1 and the x and the 1. Multiplying that out is a previous skill we need, but just be sure you don't just square the 2 and square the 1 and square the x. You need to think of it as x plus 1 times x plus 1. So let's go back to the graph. Our orange parent function is x squared. Notice what it's done. It said it moved left 1 and up 3. If we do the vertex form, which we practiced in the last example, that's going to tell us y equals x plus 1, because remember when it moves left 1, we do the opposite, and my k value will be 3. To figure out this a value, I'm going to forego that whole substitution thing. I'm just going to check. This little function goes over 1, up 1, just like its parent function does. So we're going to know that that's just a 1, and it also is opening up. So we are done with vertex form. But now, they want us to also write it in ax squared plus bx plus c. That means we need to take this vertex form and multiply it out. So just as I mentioned before, when you see x plus 1 squared, as we do here, we need to write it out as x plus 1 times x plus 1. Let's go ahead and try that. X times x would be x squared. X times 1 is 1x. 1 times x is 1x. And 1 times 1 is 1. If I multiply x plus 1 squared, I get x squared plus 2x plus 1. That is just the x plus 1 squared part. So this part right here, when I squared it, becomes this. Now notice I still have, don't forget, you still have the plus 3 here. So I'm going to put plus 3. So my final answer, also we should note, there is a times 1 here, but anything multiplied by 1 won't change it. So I don't really have to times by 1 here, but I could eventually. So I will have x squared plus 2x, and 1 and 3 are the same common terms. They're just a single number. So 1 plus 3 would be 4. This would be my standard form. That looks like a normal parabola we've seen before. To finish off the video, I'm going to do just part B of the triads. Let's do part B. So we have, it's reflecting over the x-axis. Remember, that is like flipping upside down. So we have a sad parabola, and it is moving down 1 unit. So if we start our vertex form, we know our a value is going to be negative. And when it talks about moving left and right, there is no movement left and right. So I can put a plus 0 here if I want to. You don't have to. And our unit down means a negative 1 goes out here. So because it doesn't tell us that there's a vertical stretch or compression, we're going to just assume that this is going to stay the same shape or compression or stretch, as if you will, as x squared. So we would say our new equation is negative x squared minus 1, which you don't really need the parentheses then. It would just be negative x squared minus 1. Now with this one, nothing really changed much. This is kind of your vertex form, I guess you could say, but really there's not much different because we don't have that horizontal shifter. Check your answer key for part A.